Okay, this is section 2.6, Piecewise and Absolute Value Functions, Part 2. From the notes worksheet, number 5, we have 3 equations that we have to graph. The very first one is g of x is equal to x. That is the same thing as saying y is equal to x plus 0. So your slope is 1 over 1. Your b is 0, 0. So that means it goes to the origin. So make sure you label your x and y axis so it goes to the origin at 0, 0. We're going to go up 1 over 1, up 1 over 1, up 1 over 1, or we can go negative 1 over negative 1, which is down and backwards. Now, before I draw my lines, I'm going to look at my boundary. My boundary is x is less than or equal to negative 5. So here is my boundary right here. So I'm going to extend the lines to the left or to the right of this boundary. To the left, because it's less than negative 5. So which points are less than negative 5? To the left. So, and it's going to be a closed circle at negative 5, and my line goes to the left. So all these points to the right I'm going to erase. The second equation is g of x is equal to 2x plus 3. That is y equals 2x plus 3, where your slope is 2 over 1. Your b is 3, which is the ordered pair 0, 3. So I'm going to plot 0, 3, and I'm going to go up 2 over 1, up 2 over 1, or, to go in the other direction, down 2 backwards 1. Now, my boundary is negative 5 is less than x is less than 2, but we don't say it that way. How do we read this? X is between negative 5 and 2. So here's my boundary at negative 5 already, and here's my boundary at 2. Now, they are both less thans. So are we going to have an open or a closed circle? Open circle right here at negative 5, and an open circle right here at 2. So our line goes from those two open circles. Okay, does everyone agree with that? And then your third one is y equals negative 3. That's a horizontal line at negative 3. But the restriction is from 2 to 6. So I already have one boundary at 2. So I'm going to make one right here at 6. So it's a horizontal line, and it's closed circle at both negative 2 to 6. Okay, so if you want to erase your boundary points afterwards, you're fine. You can keep them. That's okay too. All right, now, it didn't ask to state the domain and range, but let's do that. What is our domain going to be? Negative infinity to right here, and what is that? 6. Bracket. Very good. And our range is going to be from negative infinity to right here, parentheses, 7 in its parentheses. Very good. Okay, this is from number 4 from your notes. There's graphs. Now we're going to have to go backwards. You're given the graph, and you have to come up with the equation. Okay, so it's a little bit more complicated. Okay, so we have 3 graphs. We have to come up with the equation. We're going to look at the first one. I like to start from the far left. You can call this f of x or g of x. I don't really care. I think in your worksheet it says g of x. This first graph right here is a horizontal line. Horizontal line is y equals, and it's 1, 2, 3, -4. Correct? So right here, I just put the -4. Now we have to state our restriction. What is our boundary? Right here at -2. So our boundary is x is less than or equal to -2. And then the second line, I have to get that in slope-intercept form. Now I can see by looking at this line, it crosses the y-axis right here at this point. What is this point? -3. So I know that my b is -3. Now I'm going to rise over run, go up 2 to the right 1. Do it again. Up 2 to the right 1. Up 2 over 1. So what is my slope? 2 over 1, but I'm just going to say 2. So that is in slope-intercept form, 2x, y equals -2x minus 3. When I go to write it right here, I just write the 2x minus 3. My restriction is it's between -2 and 4. 3. Thank you. So I'm going to put less than signs. Now on -2, it's an open circle, so I put a less than sign. But on 3, it's a closed circle, so I'm going to put a less than or equal to 3. In the third equation, it's a horizontal line at 7. So that's y equals 7, and we write 7. And the restriction is x is greater than, it's an open circle, at 3. Okay, any questions on that one? Example 4b. We're going to write the equation of the first line. Now, this equation right here does not show where it's crossing the y-axis. But can I get my slope? Yes. So just randomly put your pencil on any point right here. You go up 1 over 1. Up 1 over 1, up 1 over 1, up 1 over 1. So what is my slope? 1 over 1, which is 1. Or 1. The slope is 1. It's not x. It's the number in front of x, which is 1. Now to put it in the form of y equals mx plus b, then you write 1 equals 1x, or you could say x then. I understand what you're saying. We had to calculate your b. How could we find our b? Just extend the line. Go up 1 over 1, up 1 over 1, up 1 over 1, and you would land right there at 4. So 4 is my b. Now I need to make my restriction. My restriction is if x is less than or equal to -3. Y'all agree with that? Okay, now the second line, I'm going to erase this. The second line, I've got to look right. I can see on the graph that it is hitting my y-axis at what point? 1. So my b is 1, and I went down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. So my slope is -2 over 1. So what is my slope? -2. So when I go to write the equation as y equals -2 plus 1. But when I go to write it right here, I write it as -2 plus 1. Now there's a restriction. It's an in-between. So I put less than signs on each side. Far left, the restriction is -3. Is it an open or a closed circle at -3? Open. So I do not put a line underneath. And on the far right, it's a +3, and it's a closed circle, so I put a line and put 3. So y'all try the third equation. The slope, I can tell, is 1 over 1. We all agree? Up 1 over 1, up 1 over 1, up 1. Now, you'd have to extend it down and backwards, down and backwards, down and backwards. Down and backwards, down and backwards. And it lands at 0, 0, right? Let's pretend that we can't extend the graph. What's another way of finding your b? Do y'all know? Pick some point, because this is going to happen on your homework. You're not going to be able to see where it extends. You know that your slope is 1 over 1. Just pick a point. Let's pick this point right here. What is this point? 1, 2, 3, 4. 1, 2, 3, 4. 4, 4. Plug in your slope as 1 and the point 4, 4 and put it into the point slope formula. So everyone do that right now. Yes. So when we solve, we're going to add 4 and we get 0. So that's y equals 1x plus 0, or y equals x right here. And the restriction is x is between 3 and 8. And they're both open circles, so we do not have a line. The domain would be negative infinity to 8 because it stops at 8. And the range would be negative infinity to stops right here at 8. Okay, f of x is equal to absolute value of 2x minus 4. The parent function is f of x is equal to absolute value of x. That is a V shape that goes through the origin. It looks like this. So this is the parent function, the absolute value of x. Remember, when we add or subtract something to the end, that shifts it up or down. So that minus 4 means we are shifting it down. It's going down how many places? 4. So now the vertex is at what point? 0, negative 4. So we slide it down. Now, if you notice, there's a number in front of x. What is that? We've never had a number in front of x before. The number in front of x, just like when we did slope-intercept form, when we graphed a line y equals mx plus b, that m was our slope. It determined how steep our line is. Same thing with absolute value. So from your vertex, we look at our slope is 2. So it's 2 over 1. So go up 2 over 1, up 2 over 1, up 2 over 1. That's one leg. To get the other leg, we're going to do the same thing. We're going to go up 2, but we're going to go back 1. And do you see that it's a little steeper? So we can draw our line. Now another way we could graph this is make a table. If you didn't follow what I just did, make a table. Let's pick negative 2, negative 1, 0, 1, 2. So let's plug in right here. When we go to plug in negative 2, that's 2 times negative 2. That's the absolute value of negative 4, which is 4. And 4 minus 4 is 0. Fill in the rest of this table for me. So we finished the table. Now let's plot these points and see if they land on our graph. Negative 2, 0 is right here, landed on our graph. Negative 1, negative 2, landed on our graph. 0, negative 4, landed on our graph. Do you see that all these points on our table landed on our graph? So it's much easier to graph the absolute value using our transformation rules. Okay, copy that one down. Okay, don't forget, let's do our domain. Our domain is all negative infinity to positive infinity. Our range starts at negative 4 to infinity. Okay, example B, absolute value of x minus 2. Now, when there's a shift, when there's something inside with the x, it shifts to the right or to the left. And remember, it's always the opposite. So that's x minus 2, so that means we shifted to the right or to the left 2?
Right.
To the right 2 places. And to get the rest of the points, what's in front of x? A 1. So we can go up 1 over 1, up 1 over 1, or up and backwards to get both v's. The domain is all real numbers, or negative infinity to positive infinity. Our range is, what's our range? 0, and 0 is included, so bracket to positive infinity. Okay, now example C, this one's going to be a little bit more complicated. So we have 2 transformations. What is the negative in front of the absolute value? It's a flip. And then it slides up. Very good. So our vertex is going to be, where's our vertex going to be?
1.
At 0, 1. And it's going to flip downwards. But our slope of our rest of the points is still 1 over 1. But it's going to be down and backwards, or down and to the right. And our domain is negative infinity to positive infinity. Our range, now let's be careful about this. It's going down, so what's, it keeps going down, so it's negative infinity to what? To 1, and 1 is included, so it's a bracket. Now from here, you have to come up, you're given the graph, and we have to come up with the equation. So it's going backwards than what we just did. Well, I know this is an absolute value, so I know it's a v, so it's an absolute value, so I know it's going to be absolute value of x. Did I shift it up or down or right or left? No, but it looks steeper, doesn't it? So from my vertex, I'm going to figure out what is the slope. I went up 2 over 1, up 2 over 1, up 2 over 1. So my slope is 2. Now I know the equation is f of x is equal to absolute value of x, but what goes in front of x? The 2x. We did not slide it up or down or right or left, so there's nothing to add to it. Now, guys, with absolute value, you can have the 2 inside with the x, or it can also be written with the x in front of the absolute value symbol. That means the same thing. Okay, so if you have the 2 right in front of the absolute value, that still this is your slope, or you can have it inside with the x. That means the same thing. So you need to know it can be written either way. Let's look at example 6b. Now this one, it's shifted and it's really, really wide. So it doesn't really matter which one you do first. From the vertex, I want to calculate my slope. So I went up 1 over 2, up 1 over 2, up 1 over 2. So what's my slope? 1/2. And it shifted to the left 2. So it's opposite, so it's going to be absolute value of x minus 2, because it goes inside the absolute value. Now, I can either choose to put the x in front of the absolute value. Don't forget your f of x part. Like this. Or you can choose to put the 1/2 inside the absolute value in front of the x. But the minus 2, the shifting minus 2, excuse me, I did that wrong, didn't I? What should it be?
Outside.
It should be, no,
Oh, plus
should be plus 2. But again, the half, it can either go in front of the absolute value or with the x. They mean the same thing. And what would the domain be here? Negative infinity to positive infinity. And the range is 0 to infinity. Try this one. The vertex is at 0, -7, and your slope is 2 over 1, correct? Now, the shifting goes down, so does it go inside the absolute value or outside? Outside. The slope, you could write it with it or in front of the absolute value, and then -7, or you could, f of x is equal to absolute value of 2x and then -7. Either one would work. And that is the end of section 2.6.